Porto, city of Portugal. Oh, okay. We will study the impact of vibrations in phase transition. When we are boiling water, you can see the formed bubbles going up due to buoyancy. This only occurs because we have gravity. If we are in microgravity conditions, the bubbles want to go up. Instead of going up, they will spread all over the sample. This will make the phase transition slow down. But recent researches made by Mr. Basins had observed that if we induce a vibration, we can accelerate the phase transition and almost simulate the gravity effects. But so we will study the phase transition of CO2 and SF6, and we will induce a vibration and compare the results in gravity, microgravity, and with the vibration. But we have a problem. Even in microgravity, the phase transition is slower. It still is really fast, so we can measure it. So we have to use supercritical fluids to measure the bubble size. My friend will explain it a little bit.
Okay, hi. So what is a supercritical fluid? It happens that when you go above if you increase the temperature and pressure, there is a point where when you go above it, the distinction between gas and liquid vanishes. What does this mean? This means that the fluid is neither a liquid or a gas. It's something else. It's a supercritical fluid. And it has very interesting properties. For example, it has applications in fuel extraction when we get to Mars. But the most interesting property we will use in our experiment is the critical slowing down process. What happens is that when you go really close this point, the critical point, the time and space scales of the sample diverge. What does this mean? Practically, it means that the bubbles that form, we have a picture here of a sample near the supercritical. These little bubbles will be bigger than in this place here, or something. So, and the phase transition will be slower, a little bit slower. So. Now our setup, since we are going to test with CO2 and SF6, we'll have two identical boxes with the same setup inside, but at different pressure and temperature points. Inside the boxes, we'll have a vibration mechanism that will vibrate to all setup. This part of the setup, and here we'll have a very small cavity around 2-3 millimeters diameter and 1 centimeter height, cylindrical, with the sample. For example, for CO2, the sample will be at 33 Celsius degrees and 70 atmospheres pressure. So it's a really high pressure inside it. We'll have a very precise thermostat, because we need to do the temperature ramps near the critical point very slowly. We are still designing that system, and then we will record what happens. So we'll have similar images than what has been done in this paper. And then we'll process the bubble size and yield the evolution of the mean bubble size through time by two-dimensional Fourier analysis. And thank you. We're the Sky Seekers team, and we would like to thank all of the organizers, our teachers, and everyone that helped us. Thank you.
Seconds. Uma vista.